Today we have a very interesting and exciting AI solution for you. Welcome to this AI bootcamp, and I hope all of you are having a lot of fun learning the rest of the part of this bootcamp conducted by Ivy. And I'm going to share a pretty exciting project that we've recently done at Ivy. A lot of our students have taken part in it, and we have actually done some quite amazing work. This is the aggregation of all of that, and I am going to help you understand how this entire thing works. Okay, so today, guys, we are going to predict the winner of the ICC World Cup 2023. So we all know that right now the World Cup's going on. The matches have started. Every day there's two matches, ODI 50-50, etc. And using AI, can we really solve and predict the World Cup winner for ICC, right? That's our challenge. That's our task for today. So with this bootcamp, you will get to learn four very crucial things. How do you explore data set of this kind? So, well, you can learn data sets and data science theoretically, but unless and until you've gone through a lot of different data sets of different domains, you will not be able to get the confidence to go ahead and solve any data science problem. So it is essential that you go through different types of data, one of them being a sports, such as this, a cricket-based data set. This could be any other sport like football, rugby, etc., etc. Right? Now the intention is, once you have this data and once you've understood this data, right, you need to understand how to clean and prepare this data as well, right? So how do you do that? Starting from the initial data analysis, exploration, right, understanding the different data types and stuff, what are the ways that you can prepare this data to eventually be fit for machine learning? And finally, once you have the clean data, how do you leverage different machine learning and AI tools to create a machine learning model that can predict the winner of every single match? Now, one very crucial aspect of this entire project is that it is a sequential game, right? Why do I say it's a sequential model? Just think about that. Suppose there is team A and team B. Then there is team B and team C. Okay. And finally, there's also a match between team C and team A. Now assume that this is a elimination matches. Okay. That means in fundamentals, if between the match of team A and team B, if team A loses, okay, if team A actually loses and the winner is team B gets to play with team C, right? So team B here has a chance of winning since it won the match before. Okay. But because team A has already lost and this was an elimination match, team A never gets to play against team C, even if team A was stronger, it won't be able to play. Is that clear? Right? Guys, I know you're all on YouTube Live, so just put a yes or no on the YouTube Live channel. And I am monitoring the same live, so I'll get to know if you guys are following up. And if there's any questions, please post on the YouTube Live chat. Right? So the model, the machine learning model that we are going to build is not going to be a completely independent or individual type model. It will be sequential. That means the outcome of one single match will define what other matches will be played. Okay. So let's get that out of the way and move forward. And after we build all of this, right, first we get understanding of the data, process it, build a machine learning model. Then we'll basically figure out how to use it anytime we want to come up with an outcome of any of the matches. Okay. Now, very, very important concept. Requirements.txt. So all of you who are new to Python or who are new to technology in terms of development, in terms of programming or coding, there is something called as the requirements.txt file in every project, right? If you go to any project that was built using programming or coding of some kind, it has a requirements.txt file. What is a requirements.txt file? It is a file which contains all the packages and libraries used in the project, along with the specific version they were used as, right? If this project, if this notebook that I created was built with Pandas 1.5.3, and you on your system have Pandas 1.2.6, let's say, right? There are high chances that the code that I've written here might not work for you. So requirements.txt is actually essential for you to make sure that whatever code is written here, all the Python code that's written here is also accessible and executionable for you, right? So we've had the requirements.txt file. We'll share this entire zip folder with you. All you can do when you are running this project, you can just simply do a pip install -r requirements.txt. What this command will do for you is it will install all the libraries with the specific versions on your computer. So you can run the code in the exact same environment in which I have run the code. So that is why it's called setting the environment. Okay. Next is importing all the necessary packages that we are going to need throughout this project. So I'll import Pandas. Pandas is the data analysis library of Python. It's one of the most used, most sought after package used across a lot of projects, has been contributed to by a lot of intelligent and proficient programmers. Same for NumPy. NumPy is the numerical Python library, which enhances different kinds of matrix-based operations, arrays, etc. Then there's the visualization library, and then there's a more advanced visualization library called Seaborn. So let's just first understand the data set. What kind of data is available to us for us to make the prediction of who's going to win the ICC 2023 World Cup? Okay, so we have this data.csv. What's this data.csv? It basically has a description or I would say a fingerprint of all the playing countries, right? So there is the team name. What are the teams that are playing? These are the teams that are playing. What is their current team ranking? What is the number of titles these countries have won? What is their winning percentages in ODI? What is the number of World Cup matches they've played? What is the number of World Cup matches they've won? What is their World Cup winning percentage? What is their match loss in the World Cup? What is the loss percentage in the World Cup? Now, look at this closely. Whenever you import any kind of data set, you will always have this description of the data. If you don't have it, what can you do? You will have to ask the client. You will have to ask the customer. You will have to ask the domain team, whichever knows the data well. You have to ask the database manager, whoever it is. Unless and until you are clear about every single aspect of the data, you should not be moving forward with any kind of analysis, reporting, visualization, modeling, because it's a very age-old saying in machine learning: garbage in, garbage out. So always know the data first and then start working on it. Okay, that's why we have the description here, the team name, team ranking amongst international cricket teams, titles, number of ICC Cricket World Cup titles, winning percentages in ODI, etc., etc. Number of matches that ended in a tie, number of matches that ended with no result, whether the team has won the ICC Cricket World Cup, yes or no. Have they won at least once? What is their recent points or rating? Like what is their current status? And what is their rating in international cricket? So this is our data.csv. Let's load it up. Data.csv, and this is my data. Okay, so I have 10 teams. I have their rankings. I have their titles, number of titles, win percentage, ODI, World Cup matches, etc., etc. All of this data is available. Now, why is this data essential for me to be able to predict the potential performance of the team, right? See, historical performance of the team gives me a huge representation of the possible future performance, right? How a team has performed in the past, that past could be since the beginning of cricket, since the beginning of World Cup. That past could be recent past. That past could be last 1 year, last 5 years, etc., etc., right? My entire point of having this data and using this to model, to use inside my machine learning model, is to be able to use the past performance as an indicator for future performance. I hope that makes sense to all of you. Just put a yes or no on the chat and I know you agree. And if there's any questions, please add the same. The intention here is using this past performance as an indicator for future performance. I should be able to predict that if two teams are playing against each other, based on their past performance, which team is more likely to win? Which team is more likely to win? That's what I need to predict. Obviously, there are so many factors. One single player plays really, really well, okay, out of the box, unexpected game by one player. Let's say another player who we were expecting to play really well plays very poorly, right? Some kind of physical mishap or health mishap happens, any kind of injury happens. There's so many factors that are not in our control. And because they are not in our control, we will ignore. So we will ignore factors that are not in our control in real time, right? So there are factors that affect the system being the World Cup matches. Amongst those, there are factors that we can control and there are factors that we can't control. Our intention should be to focus on what we can control. Okay. Now, we have this kind of indication about the past performance of any country, right? So this is our data. Now, quickly, we will look at the information in the data to quickly summarize this table. So if I do a data.info, I will get that team name has 10 values. All of them are non-null. Non-null means does the data have any kind of missing value or not? So if 10 rows are non-null, that means out of the total 10 entries, all 10 of them are non-null. That means there's no missing value. Similarly, throughout this entire column, you will see 10 and non-null. So there's no missing value in this entire data. Now, team name is obviously the object type. Object type basically means string, right? It's in the string format. Team ranking is in the integer format. Titles is in the integer format. Percentage is in the float or real number format. Similarly, all the other relevant indicators of a team's performance are represented in relevant data types. Okay, so that's my first data set. Coming to the second one. Below is the description of result.csv data. Now, what is the result.csv data set? It is a date of the cricket match. A particular cricket match happened on a particular date. That date is given. Which was the first team playing? Which was the second team playing? That is given. First participant, second participant. Which team won the game? So this is again historical record of the matches that happened between any two teams. And because it's a historical record, we know which team won, what kind of margin they won from, and what was the cricket ground, right? Because in cricket, the ground matters a lot, right? We always talk about, it's a home ground match, there's an advantage. It's a non-home ground match or an outside match, not having that kind of advantage. So the intention is, we will now look, see, we have the individual representation of every team, right? That we already have. Now we are looking for when these individual teams did have a match in the past, what was the outcome? This outcome will help our model understand which of these factors is important to define a win or loss, right? Which of these factors helps define who wins the game? So we have to actually merge these two data sets together, right? So this is a representation of a team. This is the historical data of a team, right? Whatever their current status is and how they played in the past. And this is the data of both teams playing together. This is an individual team level data. This is a match data. Whenever two teams have gone against each other on a particular date, in a particular ground, who won the match and what was their margin of victory? Did they win by a huge margin, or did they win by a small margin, or did they just manage to win, right? And finally, we have the fixtures. The fixtures is the current plan of the ICC World Cup 2023. The matches that are already planned to be happening in the World Cup 2023. This is the time or plan, or I would say the schedule of the matches that's going to happen. Okay, round number of the tournament, although that's not very important to us. Team 1, team 2, which is the match, which is the team playing against which other team, what is the date of the match, what is the location, which is basically the stadium, and what is the group. The group is also irrelevant because we don't have the same information here. And finally, we have the result. This is to be predicted by us. This result is something that we will need to predict. So if you look at results, this already has the matches played on individual dates, and it also has the winner, which team won, right? But if you look at fixtures, you will see you have team 1, you have team 2, you have date. I think this has gotten shifted a little bit, right? So these are the two teams, team 1 and team 2. The date, the stadium, the location, and you have the final column where you will see that we don't know who won the match. Okay, I will just show that to you in the data set. Okay, let's start with exploration of this data. A quick task. We want to check the information of the results data frame. So what can I do? I can just do a results.info. If I do that, I see that there are 722 past match records. All of these records have values. There's no missing values. There's no data inconsistency. And all of them are in the string format. Now, why are they in the string format? Because to represent the data that we have in this, we will need the string format. Okay. Guys, I hope everyone's with me so far. Can we move forward? Quick response, yes or no in the chat, guys. Okay. Coming to the exploratory data analysis. Now, once we've understood the data, let's dig deeper into the data and understand if there are any insights that we can get directly from this data, right? So first of all, we are plotting the number of titles won by each team. So you can see There's Australia, there's Pakistan, there's India, New Zealand, England, and Sri Lanka, right? So we have all of these title comparisons. So if you look at the title, you will see that Australia as a team has the highest number of titles. Then there's India, then there's England, then there's Pakistan, Sri Lanka, almost at a tie. If you want to plot the win percentage of each team, we can see out of the matches played, but this is win percentage of ODI, by the way. So if you see this, this is ODI. In one-day international matches, the company that has the team that has played exceptionally is South Africa, right? With the highest winning percentage of the ODI games, right? But we can do a similar thing on World Cup match winning, right? Total matches won in World Cup by each team. And you would see that Australia is at the highest. Then there's New Zealand and India very close. Then there's England, Pakistan, South Africa, Sri Lanka. So guys, this is not the World Cup winning, okay? This is, if you've played any World Cup match, how many matches have you won and how many matches have you lost? That's all it depicts, okay? Now, going to the latest ICC ranking, what is the current ranking of all of these individual teams? So you can see the current ICC ranking mein, Australia is at the top, it's leading with 118. Then there's Pakistan and India with with 1 unit gap between them. And then there's New Zealand, England, South Africa, and countries in that order, right? Now, first of all, like I said, once we understand the data, once we get an understanding of what the data has, what can we do with this data, and what are the, I would say, information available with the data, we will now be cleaning the data. Now, it's very important to clean the data because if you do not clean the data, you will be passing information to the machine learning model that will not help it learn, right? So we need to make sure our cleaning is done well. So what are we doing here? The first thing that we want to do is we want to remove or drop any match out of the results data frame which did not have a conclusion or a conclusive output, right? If there were so many matches, 722 matches, there are a lot of matches where there was no conclusive outcome of the match. You could easily find that out if you look at the winner column and try to do a value counts on it. And you will see India, England, these are all countries that won the match. But then there is this no result. Then there is this match abandoned, right? These are cases where it's not something that we can help the machine learning model understand, right? So the model will not be able to figure out how to understand if a match is going to be tie or a match is going to be abandoned. And considering the probability of a match being tie or abandoned also being very low, we can safely ignore this case. Now, one very, very interesting aspect that a lot of you might have noticed here. Can you see India being here twice? India comes twice in this. Now, if you're ever stuck with something like this, you should actually do a unique operation. When you do this unique operation, you actually get the number of unique values. Can you see there is data discrepancy here? Yes, we will be sharing all the CSV files as well as the notebook. Don't worry, guys. This is for everyone. We'll give you an entire zip file. Can all of you notice there's India and India, 2 cases? Now, this is a common problem with data processing, right? You will see that the data is the same. It's just that there was an extra space because of which Pandas and Python is considering this Sri Lanka and this, there's another Sri Lanka somewhere, this Sri Lanka to be different, while they're actually the same, right? So we have to figure a way out to clean the data. How do we do that? Let me show you a very interesting way to do it. In the winner column, I can apply a string-based method. Okay. Apply string method on pandas series. I'm looking at a query, and using string methods in pandas, I get an entire detailed analysis. And you can see I can pick up any column, and after applying the .str, I can apply string methods. What are string methods? You can quickly see Python string methods. So all the Python string methods are available to us. And in that, there is something called as rstrip. Returns a right trim version of the string. So if you see this, I can quickly show you an example out of it, so you get an understanding first. See, this actually strips the right-hand side. There was space on the right-hand side. There was space on the left-hand side. It did not fill or remove the space on the left-hand side. It actually stripped the space on the right-hand side. So I can just do a rstrip here. And that would actually strip my column of extra spaces on the right-hand side, which is the problem that I see here, I see here, I see here, and a lot of other cases. And I can just say that this is my new results winner. I updated my column. And now if I do a value underscore counts, it looks much better because now I have all the team names uniquely present in the data. I only have match abandoned and no result in these cases. Otherwise, everything else you will see, right? I can remove these two and everything else should stay. That is why I'm going to run this. I just dropped all the rows, all the indexes, basically rows and indexes are same in pandas. I dropped all the indexes where the winner column had the value match abandoned or no result. I dropped both of those cases. Okay. That's my first step of cleaning. Now, let's see how Indian team performed in the past World Cup matches. So to find that out, we are trying to filter out any case where the Indian team played, all matches played by the Indian team. Now, when we look at the results CSV, this results data frame, India team could be the team 1 or it could be the team 2, right? To consider if India played a match or not, India would either be playing in team 1 or be playing in team 2. So what do? Results team underscore 1 equal to India, or copy paste team underscore 2 equal to India. Now this gives me a Boolean response. See, in the first row, team 1, let me go to the results CSV. See, in the first row, team 1 was Bangladesh, team 2 was Pakistan. Neither of them are India, right? So there is a false. To look at all the cases, now there are trues in the middle of this. Obviously, the Indian team played a lot of matches, but we can't see it because it's a pretty long list, a pretty long set of true, false, true, false, true, false cases. If you want to visualize only the true cases, you can just put a results in the beginning. And these are all the matches, 106 matches in total in the World Cup where Team India was playing against any of the other teams, right? And you can see in how many cases India has won, in how many cases India has lost. We can calculate that as well, right? And suppose in this particular case, when Bangladesh won, they won by 79 runs. In this case, when Bangladesh won, they won by 6 wickets. In this case, when India won, they won by 77 runs, won by 4 runs, won by 62 runs, won by 8 wickets, etc., etc. That's the margin of win. Okay, so I'll just take that entire data and call it India. And then I will see all the cases where India won. And you will actually see that there are 73 out of the 106 cases we filtered out where India won the match. So 73 out of 106, that's 68.86%. Not a very good average, but obviously as Indians, we want more, right? As cricket fans, we want India to win all the time. Okay. Now, number of wins in ODIs against other teams, right? So I do all of that calculation. What do? I first create a India won matches data frame. What's that case? It is the case where first India is either team 1 or team 2, right? See, this is India win. I created a data frame where I filtered out all the cases where India had won, right? These are all India win matches, right? Either India played with team 1 or India played with team 2, right? Determine the opponent team. Now, what do I want to know? Whenever we've played and we won, who have we won against? And how many times have we won against that team? Okay. So, when India did win, who were the opponents? This is the case where if team 1 is India, opponent becomes team 2. If team 2 is India, opponent becomes team 1. That's the kind of processing I am applying. So once I have all the cases where India won the match, I am finding out all the cases where I want to know who was the opponent. When I want to know who was the opponent, I am just going to find out in a basic apply method of pandas. If team 1 is India, I will pick team 2. And if that is not the case, I will pick team 1, because if team 1 is not India, it's team 2. If team 2 is not India, it's team 1, right? So our opponents look something like this. We played against these kind of opponents: West Indies, Australia, Sri Lanka, South Africa. And these are the number of matches that we've played against them, by the way. Let me just quickly run all of this so that my data processing thing works properly. Yes. See, England has a left strip. There's an additional empty space here. We can handle that later. For now, we can just proceed with this. Right? So these are the number of times that I have played against all my opponents. So let's just put this on the top. These are my opponents and the number of times I've played against them. And I can just plot them. Now, there's some data discrepancy here again. Like I said, there are problems in the data. We need to figure out how that works. So you can see the number of unique values. Again, Sri Lanka has that problem of, an extra space in the end. So I can say .str .r strip, right, .unique. Right? And then if I do a value underscore counts, I will see that we played 14 matches with West Indies, 11 with Australia, 10 with Sri Lanka, Zimbabwe 9, New Zealand 8, South Africa 7, Bangladesh 6, England 5, England 1. So England should actually be 6. Let's try an L strip. Let's remove it from the left-hand side also. L strip does not work. Let's see what is the actual method. Right strip. Do we have a left strip? Yeah, we have an L strip, but I think we will need a .str again. Yes. So now you can see this is the distribution of all the matches that we played with all the opponents. I will just copy paste this again here and you can see. So looking at this file, you can easily understand the number of matches we've played with each opponent in cases where we won. Okay. These are cases where we have won the match, right? So if I ask you, which is the country against whom if we play, we have a very high chance of winning, you would see that West Indies is one of those countries where we've had a lot of wins when we've played against them. right? Because I filtered my entire data for cases where I have won, and this is case where West Indies leads. So now I am going to process my data to make it available for modeling. So again, I'm going to use the regular expressions. RE stands for regular expressions. This is a way to process strings, but not in the absolute format, in the patterned format, right? I want to write patterns using which I can format my strings. So you can see remove white space. It simply strips my data from the left hand side and the right hand side. So just to give you an example, if I want to call this remove white space function and I say space, this is the AI bootcamp, and I put spaces here. Can you see? It actually stripped the spaces from the left hand side and the right hand side. Okay, so I apply this on the team name. I also apply this on team 1 and team 2. I already applied them on a before to show you the right charts, but I've just applied them overall, right? These are the World Cup teams participating. These are the teams that are participating this year. I will filter out my entire data only for teams that are participating, right? For example, if there is a team X, let's take an example of team X, which has played the World Cup in the past, okay, but is not playing this year, okay, is not playing this year, then I should be fine. Why? Because when I am making a prediction, when I'm going to make a prediction, I won't get this team. I won't have to tackle this team, right? I will not have to tackle this prediction. But consider something else. There is a team Y which has never played in the past and is a new entrant in 2023. This is a challenge. Why? Because I have no history related to this team. And then that makes it difficult for me to predict performance and winning for this team, for or against this team, right? So that's one thing that ML models lack, which is you cannot show them some new kind of feature or new kind of input and expect them to make a different, still predict accurately. Okay. So I'm going to filter out both my data frames for cases where these teams are part of the World Cup teams. I will check duplicates in my data, right? And wherever there are duplicates, I am going to drop them. I will check missing values in my data. This is me preparing my data for machine learning modeling. This is not a cleaning step or a processing step. This is a machine learning data pre-processing step, right? When I'm checking duplicates, when I'm checking missing values, things like that. So this is my team's data where I have the date of the match, the team, first team, second team, which was the winner, what was the margin, what was the ground, right? Now, I don't need the date, right? So ideally, date should not affect the outcome of the match. I don't need the margin because, in cricket, how much margin you win from, or I mean, with how much margin you win is not very important, right? Either you win or you lose. The output or the outcome of the match is binary. Outcome of a match is actually binary. So we don't have to worry with what margin one team won against the other. A win is a win, a loss is a loss, right? And we also shouldn't care about the ground, although there are ways we can incorporate this. Right now, let's keep it a more simplistic model, right? We can build more complex model by incorporating home ground, non-home ground, etc. Okay. Now, what I'm trying to do is instead of this winner table, I am trying to put team 1 or team 2. So if this value matches with this value, then I am going to put team 1 or replace team 1 here. If this value matches with this value, I am going to put team 1 here. In this case, let's just take a head 10 somewhere. So team 2 also comes, right? See, England played versus New Zealand, right? England played against New Zealand and New Zealand won. So in this case, team 2 is going to come here. That's what I'm trying to do with this function, right? So if whatever value was inside the team 1 is equal to the value inside the winner column, I'm going to replace team 1. Otherwise, I'm going to replace team 2. And I'm going to apply this on my teams. So let's check the teams. See winner, team 1, team 1, team 1. In this case, you can see winner, team 2, team 2, team 2, etc., etc. So whatever came on the left-hand side, which one of these teams is going to win, that is going to be predicted here. Then I'm going to further process my data in such a way that I can merge my original data with the team's information. How do I do that? You see, merge data 1. What did I do here? The team that was playing, I actually added their ranking, their titles, their winning percentage, their World Cup matches, etc., all on this side. See, whichever was team 1, I added their entire data set with a suffix of team_1, team_1, team_1 for all individual information that I had seen in my original file. Remember the first file that we went through, this one, the data.csv. I have replaced the team 1, the team name, with all the information I have about the team. And I have done the same for team 2, by the way. When team 2, in this case is Pakistan, you see I have the entire information about team 2. Their ranking, their titles, their winning percentage in ODI, etc., etc. So now I have 2 data frames where for each of the teams participating in a match on a particular day, I have their additional information that I fetched from their past performance is now included. Okay. I am now going to specifically pick only certain columns and concatenate this data in such a way that now date is there, the winner is there, the margin and ground is there. I can remove these. But now I no longer have team names. See, I no longer have any of the team names. I have represented a team based on their historical statistics. If you want to take anything from today's webinar, take this. Okay, if you want to take back any information or logical approach towards solving a data science problem, this is that very information. Instead of using the team names, India, Pakistan, Australia, New Zealand, England, etc., as inputs to the model, I have replaced them with their representation. What is their representation? Their representation is their past performance. Did everyone understand this concept? Guys, online, everyone, I hope this makes sense. All of you. Instead of using the team names and giving it to my model to make a prediction, I am directly replacing the team names with their performance. So you see, entire team one's performance is here. This is team one's performance. Okay. And then there is team two's performance. I no longer have the name of team one or name of team two. And once I have passed the team one or team two performance, all I have to do is predict which team one or team two. Right? I check out my entire data. I do the fill missing values, although there was no missing value, so I don't need to work on that. And finally, I replaced my team one as 0. So in my winner column, this particular column that you see here, I am replacing team one and team two with numbers. Why? Because machine learning models don't understand text. You have to transform your textual or string-based data into numbers for the machine learning model to be able to make a decision, right? Because machines work on mathematics, on computation, numbers, not strings, right? So all the cases where team one had won the match, I put 0. All the cases where team 2 had won the match, I'm going to put 1. So this is where team 1 becomes 0, team 2 becomes 1, right? Now, once I have this data, see, everything is a number. The entire data is in a numerical format. I'm going to now apply my machine learning principle. So first, I'm going to split my data into training and testing. So for that, I have imported my train test split from the scikit-learn package. Scikit-learn is the machine learning package of Python. Then I first split my data into all the inputs and the single output. The output is which team one or team 2, which is basically 0 or 1. And the input is all the performance metrics of these teams, right? Then I split my data into training and testing. And then I follow the general procedure of building a machine learning model. If you don't understand this well, don't worry. Whenever we go through this, fundamentals of machine learning and Python with machine learning sessions, we have like 4 or 5 hours spent just on this, all the nitty-gritties that go on behind this code, right? Behind this program. So we import a machine learning model called the random forest classifier. We initialize it with 100 estimators, max depth 6 and random state 0 for replication and repeatability. Then we fit this model with our training data. We predict using this model on our testing data, and we find both the scores, the training score as well as the testing score. We print both those scores and we see that the scores are very similar. That means my model has really, truly learned the pattern behind predicting which team is going to win based on their past performance. So what has just happened is my model performed with a certain accuracy on the training data, the data that it had seen while learning the pattern. But my model also performed with a very similar accuracy on test data, which is brand new data which my model has never seen. And since the performances are so similar, I can say I can trust my model to have learned the inherent pattern, the pattern within the data. And that is where I can now proceed with this model to make a prediction. Now that I have fixtures of my data, I have the upcoming matches in the year 2023. I'm going to clean them in such a way that I'm going to just have team 1 and team 2. All the other information for me is irrelevant. There is no result column for me. So there's team 1 and team 2. I'm going to replace team 1 with team 1's statistics, team 2 with team 2 statistics, and organize my data in such a way that it becomes in this format. And then I can predict my winner. So all of these features will be derived from team 1. Whichever team is going to play, this is going to be team 1. And whichever other team is going to play, this is going to be team 2. So I'm going to replace, in this case, let's say England with everything, all statistics about England, and New Zealand with all statistics about New Zealand, right? I will do that entire manipulation. You can see I will remove the white spaces. This is again cleaning the data. I will only pick team 1 and team 2 because all other information like ground, round number, date, etc. are irrelevant for me because my model was not built on that information. And then I will do the entire merging and concatenation operations that I did before to come up with team 1 statistics and team 2 statistics. Once the test data is ready, we'll feed it to the model to predict the output. And now my model is predicting for each of the match which country or which team is going to win, right? Now, instead of 0 and 1, which is very hard for me to understand what is the meaning of 0 or what is the meaning of 1, I already know that team 1 is 0 and team 2 is 1, but I'd still like to replace it back with the team names, which is why I replace it back with the team names. And I see that out of all the teams that have won any kind of match, this is their statistical distribution. So for all the matches that are going to be held, India, thank God and luckily, shows the maximum number of wins, right? Then England with the next highest maximum number of wins. Then there's New Zealand, Australia, Pakistan, South Africa, etc. Right? And if you want to see which are the matches that will be played in semifinals. So in the initial set of matches, not a lot of decisions are made. You know, countries start getting eliminated from the semifinals, right? So we are filtering the data for the semifinals, right? These are all the teams that have qualified for the semifinal data, right? And we are then finally aggregating and merging them. Once we are aggregating and merging them, we finally get our predictions for semifinal 1, right? So over here in the semifinal, where the prediction is 0, the team 1 was India. That means India is going to win the semifinal 1. In the second case, again, the prediction was 0, but in this case, the team 1 was England. So England is going to win the semi-final 2. Both the countries that qualify for the finals are the ones that have qualified semi-finals. So India and England are going to play the final match, in which case India is going to be team 1 and England is going to be team 2. And once I make the prediction, I see that the prediction of my model is 0, which means as of the machine learning AI model and its analysis of the past, India should be winning this year's ICC World Cup 2023, right? I hope that good news has made everyone happy. We are not just saying that, you know, India has this, India has that, that's why we're going to win. We have a machine learning model to prove that conclusion, right? And this machine learning model is not working on emotions. It's purely working on the mathematics, the indicators that represent the performance of a country, right? That's what we are using to predict which country is going to win. I hope that I was able to excite you guys towards doing this project yourself. You can try a lot more things. You can come up with other indicators of a country as well. You can come with recent indicators, things like in the last 3 months, how many matches have they won or lost, which could basically represent the current form of the team, right? Average run rate of the batsmen in the team, average wickets per match of the bowlers in the team. All of this could be considered for a timeline of, let's say, 6 months. And that would tell you that the current World Cup squad of all of these countries, what is their current performance or current form? And using that current form, you can actually predict which team is going to win the match. Okay. There's 2 minutes remaining. I'll open the forum for questions. Please post your questions on the YouTube chat if you have any questions. Okay, as I see there are no further questions. I hope all of you enjoyed this bootcamp, and we will share the entire zip folder of notebooks and data files of this particular project, and we would encourage you to try this out, create new set of analytics, post us, just tag us on LinkedIn with all the kind of interesting insights that you found on this data. And if you could get a better accuracy with different models and hyperparameter tuning, etc. And let us know that you enjoyed this bootcamp and this particular use case. And let's hope that India wins the World Cup 2023. Thank you for your time, everyone. Have a great day.